In this content, we will be looking at the Turkish drone, the Bayraktar TB2, the features of the drone, and a little sneak peek on the technology inside it. We will also look at the very basic step-by-step process of how it works, the engineering powering it, and last but not the least, the laser and GPS technology. The American drone MQ Reaper cost around $30 to $100 million per unit, while the Russian drone is expected to cost around $20 to $50 million. Beating all that is the TB2 with only $5 million is the reason why it is popular for many countries, because of its low cost and ease of use. Also keeping in mind, this comparison is only about price and not capabilities. The Bayraktar TB2 is an unmanned aerial vehicle with angled wings and a rear propeller often referred as a medium-altitude long-endurance UAV. The system consists of Bayraktar TB2 armed UAV platform, ground control station, ground data terminal, remote display terminal, advanced base with generator, and trailer modules, which we will explain later in the video. For now, let us look at the features of this technology. The TB2 has a length of 6.5 meters, while the wingspan is around 12 meters. Comparing it to a person will give you an idea of how huge it is. The drone weighs around 700 kilograms, which is pretty light for a military-armed drone with an added payload of 150 kilograms. The fuselage of the TB2 are made mostly of carbon fiber composite, with machined aluminum parts at joints. Now let us look at what is inside these covers. This is the power distribution system of the TB2 that supplies power to all other avionics and checks their status, controls alternators and batteries as well. Now these are the mission control multiple communication that is responsible for the connected avionics and ensure payload operation. This is the brain of the TB2 flight control system, which is the most crucial component of an unmanned aerial vehicle platform. Moving back, we have the Rotax 912 engine. Interestingly, this is sourced from a civilian aircraft technology, a 4-stroke piston engine with 4 liquid and air-cooled cylinders. This engine will take the drone to a speed of 120 knots at a maximum altitude of 25,000 feet. It has a range of more than 150 kilometers with an endurance of 25 hours non-stop. All this power is being fed by these bladder tanks on the wing. Constructed from rubber and plastic, fuel bladders have excellent resistance to different climatic conditions. Now let us look at what makes these innocent-looking UAV a force multiplier with a budget. It can carry 4 GPS or laser-guided bomb. This is the MAM-L laser-guided bomb with a range of 15 km. This missile is used for main battle tanks and heavily armored vehicles. They have no active motor to propel it, which gives them more room for the warhead, and as a result they rely only on GPS, as well as laser-guided by the TB2 UAV. This is the Rocket Sen, MAM-C, lightweight, smart micro-munition. It has a range of around 8 km. Provides high strike precision against static and mobile targets, mainly armor and light armored vehicle. This is the Weschem MX-15D. It is ideal for medium altitude, covert intelligence, surveillance and reconnaissance, armed combat search rescue, and target designation, which we will be talking about its use later. Let us look at the basic step-by-step process of how it works. With 2 strategy. Let us look at strategy number 1. Step 1. Remote video terminal. This is carried by the soldier close to the battlefield and target is being laser designated. Step 2. Forward base data and target is received from the soldier. Step 3. Ground control station, which is being run by a pilot, payload operator, and mission commander. This is the main control center that directs the TB2 to strike the target or abort it. Step 4. Any command from the ground control station goes through the ground data terminal. Step 5. The Bayraktar TB2 platform, after getting the command, will release the weapon, which is a GPS-guided bomb. Again, this could be the reverse for strategy number 2. The TB2 drone could be the step 1, followed by step 2, which is the ground control station, followed by step 3, which is the release of the laser-guided bomb or the GPS-guided weapon. For moving targets, laser-guided bombs are preferably used. Now let us look at how this works. As explained, this is a semi-active laser and inertial mid-course navigation system. The TB2 laser points the target, and then the MAM-L is dropped and follows the path of the laser using the laser seeker. The MAM-L switches from laser to inertial mid-course navigation system if the weather is bad, but it has its own disadvantage as it cannot be deployed against moving target, but works best against giants bunkers and command post.